So good.
So let's look at this one right here. So here, this was, in this particular specimen, where most of the parietal pericardium has been removed, you can see only one of these. You see the first one coming off. So this would be the subclavian. This is the aortic aorta there, and here on this side of it, just on the anterior side of it, and adjacent to it would be the pulmonary trunk. Now between these two, it's oftentimes right in here, and that's why I have a question mark. There's the ligamentum arteriosum, which is a ligament that actually closes up after birth. There's a shunt that goes between these two, which is a ductus arteriosus. It closes up at birth and becomes a ligament, and you really can't see it in most of these things. But it's a connection between these two that holds these two together, because you don't need to be sending blood to the lungs during fetal stages because the lungs aren't functional. So instead, the blood basically shunts over because it's coming from the umbilicus, and it goes to the aorta and just gets pumped out that way. Okay. Where are we at? Pulmonary vein. Okay, so we saw the pulmonary artery here. So that's the output. Okay, that's going to the lungs. Goes to the lungs from the right ventricle, and it's going to come back from the lungs to the left atrium. Okay, and so when you do that, and again, normally you have, you have two veins that come back from each lung, but in most of these they cut them off very close to the body of the heart, and so you're hard pressed to find little buggers. Normally what you find is just an opening, which is like this one right here. This is where they would go in. It's just, oops, sorry. This is where they're coming back into the left side, and so this is the input. So the actual vessels are really not showing, and if in a couple of these they may show up, but usually it's trimmed off so that it's so close that you can't see it. Okay. Now the other one, in fact, over here, if we look at this one, yeah, in fact, in this one, it's been trimmed off to the point where the opening is right. They've cut off part of the actual left atrium, and you see a big opening right there. So normally, and actually where they actually fuse is highly variable. Sometimes you get 4 openings that come in. Sometimes they'll fuse farther out, and you have a single opening that comes in. That's quite variable in blood vessels. Okay? And in most of these, because of the way they're cut, you can't tell. Okay? So that would be the input into the left side. And so if you do that, then basically you can actually feel down inside. We'll look at what that looks like. Now the other part, the other input, it goes basically comes into the left atrium. Obviously, as we saw before, it leaves via the aorta, goes to the body, goes through the entire systemic circulation, comes back to the right atrium via 2 major blood vessels, one coming from the head, the other coming from the body, and these are going to be the superior and inferior vena cava, and that's a terrible one. There's hardly anything there. So there are ones coming from the top, ones coming from the bottom, kind of like I have my fingers here. Let's see if we've got a better one. Here's one here. This is coming from the top, so this would be the superior vena cava, and you can see it expanded right here. And the other one is the inferior vena cava. So here's the other one. Here's the other opening. So basically, you see one's coming from the head area, the other's coming from the ventral portion below the diaphragm. Okay. So these 2 inputs both enter into the right atrium. Okay. And so basically, that takes it from the right atrium that you see. I'm just kind of moving that around here. The auricle is just an extension of that. Okay, so that's basically superficial. Yeah, they come together, and that's the one. A lot of times, that's the one way you find this out is because you can't see because they've cut things off so close. you don't have equal things. So my fingers are touching right here.
I just wrote down Chinese finger trap.
Yeah, well, good. That's one way to remember it. Okay? So, now let's see. We've seen things pretty much in terms of, okay, most of the other stuff is going to be internal, which is fine. Okay? Any questions on what we've seen so far? Pretty straightforward. It doesn't look precisely like your book, so be prepared for that.
So the apex is actually at the bottom of the heart, though. Is it, I mean,
The apex is the pointy part.
Right, but it's at the bottom of the heart.
Yeah, but the base,
At the
yeah,
top.
that's just because it's oriented that way. The base is, the reason I call it the base is because that's where most of the blood vessels, and that's where all the connective tissue coverings are emanate from. So that's the base. And actually realize that this, when we start talking about this in lecture, this doesn't have any kind of bony structure to pull on. So it uses connective tissue as a kind of a fibrous skeleton for the myocardium to pull against and pull against. Okay, and so that also is emanates from the base, where it's all the connective tissue pieces are. Okay, so when we open this up, I've got several of them opened up, and they show various aspects. And there's not, I'm not sure that one is any better than the other. This is probably one of the older ones. It's actually pretty decent. Drawing up a little bit. But we can see several things here. When you put it together, you get, well, they're not the same. So these two aren't the same. I don't know where its other half went. Might be this one. Yeah, okay. So these are, okay, these two are the same, pretty close.
Pretty close.
And so that means maybe these guys are the same.
I was thinking that.
So he goes over here somewhere. Well, we'll figure it out. Okay, it's called mix and match.
This is in the test. Can we on the test? We got to mix and match on the test.
Yeah. There you go. So the point is, when we split it, what I tried to do is get this where we could see a configuration of all the things that are inside. What I did for this one and this, I think this one over here, is I put actually a string in here so you could make sure you locate the pulmonary trunk. Okay. Because when you look at this, and you can distinguish fairly easily from either one of these specimens, actually this one or that one, you can distinguish a couple of things. First of all, you can distinguish the left and right ventricles by looking at the thickness of the outer wall. So the outer wall here, very thick, that's going to be left ventricle. Here's the outer wall on the other side, very thin. In fact, the right ventricle kind of is just an add-on to the other muscle. Okay. The same thing, you can look at it over from this side. A very thin structure indeed. Now, so the central portion of this is called the interventricular septum. And in many of the specimens, it's approximated, and I say approximated, by the anterior interventricular sulcus. Okay, it's not exact, but it's pretty close. So what happens here is that allows you to distinguish the left side from the right side. Okay? So the right side, if you look evolutionarily, this is kind of a wrap-on, an add-on to the